All right, so we're ready for SAT solutions. Section 3, number 1. Before I jump into here, let's take a look. There's, they give you some basic shapes. Here's areas of shapes, circumference of circle, got special right triangles. There's volumes of different 3D shapes. So that might be a good reference. Okay, number 1, what are the sorry, one more thing. Let's get something. Right, what we're going to do is you guys have this page. Right, you've been doing this for last couple of days, of course. You have a colored pencil on your desk. So you can have you guys grade yourselves out of 20 for section 3, out of 38 for section 4, out of your total score. Then when you turn this in, I will put this number in the grade book with a grade that doesn't actually affect your class grade, but I'll give you another grade that counts for participation points, just like we've been doing FRQs all along. And so same type story. Okay, what are the solutions to the quadratic equation? Negative 3x squared minus 3x plus 18 is equal to 0. Now, you guys know that as a graph, that would be a parabola. And even if they didn't say, even if they did not explicitly say that it was quadratic, you would know it's quadratic because I see an x squared, right? X squared, x, and a constant. Now, there's a couple of approaches you could take. However you do it, one step that I like is see how all of coefficients are factors of -3? Well, 3 or -3. Maybe I'll take that up first. So I'll do -3 times x squared plus x minus 6 is equal to 0. You can do that, right? Okay. Now from here, a couple ways you can do it. I think the fastest way is just to factor it. So okay. Yeah, see the signature? All right. Have fun on the bus. Oh, is that? You're good. All right. Did you guys factor that? You guys get x plus 3, x minus 2, because you guys know you're looking for two numbers that add to +1 and multiply to -6. Good. Second. Right, now, since this whole thing multiplies to 0, if any piece of this is 0, the whole thing is 0. So x could be +2, because that would 0 this part out. Or x could be -3, because that would 0 this part out. Okay. So +2 or -3. That looks like option A. Yeah, number 1 is A. Okay. Now, alternatively, if you like, let me backtrack a little bit. You could have said this. If you ever have an equation this form, ax squared plus bx plus c is 0, can't you say that x is -b plus or minus square root of b squared minus 4ac all divided by 2a? Right? And hey, this does take that form because it's quadratic. Plug, plug, plug. Notice that how they gave it to you is very conveniently same thing as quadratic form is already set equal to 0. I mean, if we do the factoring process, we want that form anyway. Yeah, so set equal to 0. Right? So yeah, good thing to keep in mind in the future. In case they don't do that, it's like, oh, this should be good stuff I should do. What is the equation of this line? Well, so linear relationship. Should it take the form y equals mx plus b? Yeah. What is the slope, the rise over run of this line? Yeah, 2, because it's up 2 over 1. Okay. And what's the y-intercept? -2. So I should look for something that's like y equals 2x minus 2. Is that an option? Looks like C. Yeah, the answer is C. Of course, any point you could plug in, and it should work too, right? So if you plug in like +1 for x, you should get 0 for y for that point. You can do it for any point on the line. Number 3, we've got a circle with an area of 48. 48 square meters, 48. What is the area of just this sector and then just this wedge? Now 60 degrees. How many of those wedges could you fit around the circle? 6, right? You guys ever played Trivial Pursuit? There's a game piece that looks like this. You pop in those little triangles. Or if you had a pizza that was sliced into 6 slices, right? Each one would have a 60-degree angle, because 360 degrees divided by 60 degrees would be 6. Right? So this wedge is 1/6 of the entire circle, 60 over 360. What is 1/6 of 48? 8, and that's the answer. 3 is D. Number 4, which of the following is equivalent to the sum of the expressions, see, x squared plus x and negative x minus 2. And this is the sum of, that means we're going to point those together. Oh, looks like the x terms are going to cancel. And we're going to end up with x squared minus 2. Option C. Yep, or C. Number 5. Which of the following cannot be an example of a function whose graph in the xy plane has 2 x-intercepts? Okay, so we're looking for a counterexample. Now, the only way to do this is to go through each choice one by one until we find a good counterexample of a graph that has 2 x-intercepts, or could possibly have 2 x-intercepts. Option A, a function with an absolute value and real zeros. Let me set some graphs real fast, some axes. So we can graph these things. Yep, x, y, x, y, x, y, x, y. Right. So option A says an absolute value. You guys know what absolute value functions look like? Normally you take these like V-type shapes, right? Which could possibly have 2. It does say and real zeros. So another term for 0 is x-intercept. Well, in this context, if a graph has zeros, it has x-intercepts. Right. So option A, it looks like it's off the table because that could be something that could work. Option B, a cubic polynomial with only real zeros. Option B, that might possibly look something like this. Maybe I have a couple of real zeros, right? Option C, a quadratic function. Oh, you guys know quadratic. That's parabolas. You guys seen lots of parabolas in this class, like x versus t type graphs. So it looks like A, B, and C could all work. Option D, a quadratic with no real zeros. That's like if you did something like that, which has no x-intercepts. Number 5 is D. Number 6, we got the root of c minus 1 minus t is equal to 0. And what are we doing? C is a constant. Oh, if t is equal to 4, well, just sub that in right away. What is the value of c? Oh, substitute, algebra, solve. So I'm going to add 4 over, say the square root is equal to 4. Square both sides. Right? Oh, I'm so sorry. I'm getting ahead of myself. Add 1. Okay, there we go. The answer is 17, which is A. 6 is A. 6 is A. Number 17. X is equal to y squared, and 6x plus 9 is equal to -3 times 2y minus 3. Xy is a solution to the system of equations, and y is a negative number. What is the value of x times y? All right, this is going to be one of those questions that has lots of little parts to it. We're just going to have to do piece by piece. Okay. Actually, we'll graph you guys ahead of time. What I think this graph looks like, right, or could possibly look like. When you see something like x equals y squared, isn't that a parabola but sideways, right? Y equals x squared is an upward parabola. So it might be some version of a sideways type parabola. I'm just going to make up one just for like example. I don't know, something like this maybe. I don't know. And then the other equation, I see x's and y's but no powers on those variables other than 1. So that's going to be a straight line. And who knows what a straight line looks like? Maybe something like that, possibly. Now the graph I just kind of made up that might possibly be what it looks like. See how there's 2 places where they cross graphically on the xy plane? Right. So those would be the 2 solutions. It's possible maybe they wouldn't have crossed at all. There would be no solutions. It's possible that this line would be a tangent line and just touches it at one point. I mean, those are three possibilities, but let's see. We can solve this with algebra though, right? So one thing at a time here, x is equal to y squared, and 6x plus 9 is -3 times 2y minus 3. Okay? I'll solve this with a substitution. Everywhere I see an x, I'm just going to replace it with y squared, which is just right there. So 6y squared plus 9 is equal to, also while I'm at it, I'll go ahead and distribute this -3 and make that -6y plus 9. Is that okay? Oh, hey, what happens to the plus 9s?
Yeah.
Oh, okay, so I mean, at the outset, we already knew ahead of time that this was going to be a complex problem in terms of that it's going to be multiple steps. So, hey, it's really nice that they did something like this because that sort of simplifies this. I mean, I guess what I'm trying to say is if you get to the actual SAT and you see a problem that looks like it's going to be a complex problem, it's probably set up that somewhere along the line something like this is going to happen. Add 6y over 6y squared plus 6y is 0. Factor out 6y. That's y plus 1. Right? Now, from this, there's two possible answers for y. What's one answer? 0. And what's the other answer? -1. Right? Okay. I got my graph upside down. Can't let me do that. Redraw that graph, what it could possibly be again. What I was trying to. Right. So. Maybe something more like, actually, here's something like this. Okay, so we got something like that, right? Where y could be 0 or y could be -1. Right? But remember, they also had a constraint. They said they're interested in y being negative. Remember that y is less than 0, strictly less than 0, y would be negative. So let's take that one, which of course is -1, and plug it in to x equals y squared and get what is x. So if you take -1 and you square it, what is x? +1. So maybe like this coordinate right here. Right? 1, -1, right? And then finally, the last step is they say, what is x times y? What is x times y? -1. Really? Right, which is b. Yeah, 7 is b. Right, so lots of little parts to that one. Take a little time, but that's all right. Number 8. Richard either walks or rides his bike everywhere he goes. When he walks, he burns 50 calories per mile. When he rides his bike, he burns half of that, 25 calories per mile. Richard can travel no more than 15 miles per day. Ooh, I see a ceiling, like an upper constraint. But he wants to burn at least 500 calories per day. Ooh, you guys see a dilemma? He's trying to maximize his calories burned, but there's also a constraint how many miles he can walk, right? Or I should say walk or bike, right? That he can travel. Which of the following systems of inequalities represents the situation in terms of W and B, where W is number of miles walked and B is number of miles ride a bike, right? So system of inequalities. So if you end up walking and biking, remember, it can top out at 15. So it has to be less than or equal to 15. It can't be more than 15, right? So option A looks okay and option B looks okay from that constraint. But option C and D are off the table, right? Because walking plus biking, they say like he travels more than 15. No. He can only go up to 15. Okay? So we're down to either A or B. Now let's look at the calories burned. Remember, he wants to burn at least 500 calories. So if you add 50 calories per mile times number of miles walked, plus 25 calories per mile times number of bike miles ridden, it should be greater than or equal to 500. So the answer has to be B. Number 8 is B. You guys got that? Number 9. Rankine cycle is an alternate scale for measuring temperature, where the unit of temperature is Rankine. The conversion from Celsius to Rankine is given by this expression. So 1.8 Celsius plus 491. Which of the following statements is the best interpretation of the number 491 in this context? Okay. Tell you what, having taught physics so many years and teaching different temperature scales, I don't remember ever coming across this myself, but that's okay. Because I mean, the points of these kinds of questions is, can you apply critical thinking? And figure out how to interpret these. So let's go through this whole equation and figure out what means what. That 1.8 represents, I'm thinking, for every degree increase in Celsius, would you increase the Rankine temperature by 1.8, like Rankine units? And at 491, I'm thinking if the temperature in Celsius was 0, then wouldn't the Rankine temperature be 491, like Rankine units? Is that? So let's go through these one by one. The increase in, so what does 491 represent? The increase in degrees that Rankine that corresponds to a 1 degree Celsius increase in temperature. Okay, option A answers the question, what does 1.8 stand for? If they ask what does 1.8 stand for, the answer would have been A, but it's not that. Option B, the increase in degrees Rankine that corresponds to a 1.8 degree Celsius increase in temperature. That is a total junk answer. That represents nothing in that equation. Option C, the temperature in degrees Rankine at 1.8 degrees Celsius. That also is a complete junk answer. I mean, if you plug in 1.8 for Celsius, you just get some number about 500 or so. No, okay. B and C are total junk answers. Option D, the temperature increase in the temperature in degrees Rankine at 0 degrees Celsius. Yeah, that's exactly what you said it is. Plug in 0 for Celsius, you get 491 Rankine. Okay, so option D. Number 10. Which of the following is equivalent to 4 to the power of 5 over 6? Say 4 to the power of 5 over 6. Okay. Having seen quite a few SAT exams, SAT really likes these power type questions. Can you manipulate powers? Now, there's a lot of ways you could go with this question. For example, is this the same thing as the 6th root of 4 to the power of 5? Is that the same thing? Okay. It is, but that's just not an option. That's not a choice. So, okay, back to drawing board. Start again. Okay. How about this? Let me start over. 4, is that something to the power of something itself?
Yeah.
What is that? What to the what?
2 to the 2.
To the 2. Okay. Be able to do this, there's a really good chance, I mean, almost 100% chance you're going to have to do something like what I just did on your actual SAT a couple weeks from now. Okay. Okay. Now, why do I like this approach? So if you have a power to a power, what do you do with those two powers? Multiply. Hey, can you reduce this fraction? Right? And isn't this the same thing as the cube root of 2 to the 5th? Which is the same thing as cube root of 2 by 2 by 2 by 2 by 2. Okay. Huh. I mean, if I have a triplet of 2's in here and there's a cube root, guess what is the cube root of 2 to the 3rd?
2.
It's just 2. Can I just bring it out in front and call that 2? And then I've got 2 2's left, so that's 2 squared. Okay, or 2 times the cube root of 4. Okay. So okay. I think that is the answer they're looking for. Is that A? 10 is, yeah, 10 is A. Okay, you guys got A for number 10? Okay. Yep, for sure there will be SAT questions that are almost exactly what we just did right there. Number 11. Okay, so know your exponent math. Number 11, if x squared plus y squared is C and negative xy is B, which of the following is equivalent to C plus 2B? Oh, well, let's just substitute and solve. Okay, some substitute and algebra. So x squared plus y squared is C. So we're looking for C plus 2B, right? Now, C itself is x squared plus y squared. B is the same thing as negative xy, right? So I just substituted for C and for B. Okay. Hey, let's get rid of those parentheses. Can I rearrange this? Maybe take this term and push it in the middle? Is this just begging to be factored? And an x and an x. How about a negative y and a negative y? Okay. Let's do FOIL and then check our answer backwards. X times x, x squared. Y, okay, so outside, x times negative y, y times negative x, add those together, don't you get this term? Negative 2xy. And then negative y times negative y is positive y squared. Okay, so this checks out. Bing. Is that the same thing as that? And that is the answer. Option C. Yeah, 11 is C. Guys got C for number 11? Number 12, the volume of a cone is 12 cubic millimeters. What is the volume of a cone with a third of the radius and triple the height of the cone? Oh, we've done this all the time in physics, where you have some formula, and here I'll give you an example that you might remember. If you know the gravity field of the surface of Earth, and say we see another planet somewhere that has maybe a different density compared to Earth, and also a different radial size compared to Earth, and say, what's the gravity field on the surface of that planet? That's a lot like this question, isn't it? Which, by the way, is also one of your quiz questions on the quiz I just gave you guys too. So, let's see. Check this out. I'm going to draw this one all out. We got a cone that has some radial size r and some height h, and the volume of that cone is. You guys remember before we even started this, I pointed out to you guys table of values right here. Right here, volume of cone, 1/3 pi r squared h. 1/3 pi r squared h. But I want to walk you guys through this because you can memorize this like this. Pi r squared. Doesn't that represent the area of the base, the area of that circle? Multiply by the height, that would give you a cylinder, wouldn't it? Isn't that the area of a cylinder? Like base times height. And then anything that comes to a point is a third of what the cylinder would be. So like pyramids, cones, anything that comes to a point, it's a third of what it would be otherwise. Okay. But here's what we're doing. We're going to get ourselves a new cone that has a third of the radius, but 3 times the height. That's going to be a tall, skinny little thing. Something like this. There's only r over 3, but 3 times the height. So you might say, well, maybe this cone is smaller because smaller radial size. You might say it's bigger because it's taller. One of those terms is squared, and one of them is not. So yes, if you have a third of the radial size, say volume of the new cone, 1/3 pi is all there. Okay. R over 3 squared, and then 3 times the height. Okay. See how the 1/3 factor is going to dominate because it's being squared? But the factor of 3 is only linear. So I bet most of you guys see the end result of this already. We got 3 times 1/9, right? 3 over 9 is not like a third. So this guy's going to have a third of the volume of this guy. But I'll go ahead and finish this out. V new equals, okay, you take 1/9 here, pull that out, take this 3 out here, pull that out. And then leave the 1/3 pi r squared h here. Everything in these brackets is the same thing as the original cone. V new is, okay, 3/9 reduces to a third. V cone. Okay. So the new cone is a third of the volume of the old cone. Okay. Okay. Yeah, we've done quite a bit of that throughout this class. Last step though, they said the original cone had a volume of 12 cubic millimeters. So what's a third of 12? 4. The answer is B. 12 is B. Yes, good. 13. Marcy spends an average of $42 on coffee each month. She buys special pods of coffee that cost $7 each. Recently, she decided that she wanted to reduce the amount of coffee she drinks per month by 9 cups. Assuming these pods can brew 4 cups of coffee at a time, what equation can she use to determine how many dollars D she will save each month? Okay. So a couple things about this. One is that one of the important numbers, 4, was actually spelled out instead of being typed as a numeral. So maybe it'd be easy to miss that number. 4 cups per pod. Okay. Another thing is, well, I'm going to show you my own way to solve this, which is just to solve the actual problem, and then go back and see which of those answer choices would align with that. I don't know if you guys have a more favorite way of doing this, but I'll show you my way, because Right. I'm gonna solve this with dimensional analysis. Dimensional analysis. So she's trying to reduce her coffee intake by 9 cups per month, right? 9 cups per month. And every 4 cups is equivalent to 1 pod, right? That was the number that was easy to miss because they spelled it out. And every 1 pod costs $7. Pods, cups. Do you guys see it's going to be dollars per month that she saves? Right? So yeah, at this point, we would have answered the question. How many dollars per month is she going to save? They also gave you a red herring number. They told you she spends $42. You never needed that number. So what is 9 times 7 over 4? I'm looking at $15.75. Right? That's how much money she actually saves. Now, I wish that had been one of the choices, but they went with some expression setup. So that's okay. What I would do at this point is just go through the answer choices one by one until I find one that matches $15.75. So let's do that. Let's start with option A. 4 over 7 times d is equal to 9. Okay, well, I'll take that 9, cross multiply it to 7, divide down the 4. Let's see how many dollars option A says. What is 9 times 7 over 4? That's exactly the answer, $15.75. So option A must be the answer. 13, yep, 13 is A. That's it. So fast forward, move on. I don't know, did anybody solve that with a different method that maybe I don't know, but you guys might?
I just guessed and I did I did 7 fourths instead of 4 sevenths.
Okay, but here's one way to do it anyway. So number, yeah, thank you. Number 14, at a juice bar. S servings of banana smoothie are made by adding B bananas to a blender. Okay, so we're adding bananas, we're making some smoothies. If S smoothies equals B bananas minus 4, how many additional servings of banana smoothie can be made with each additional banana? So isn't this y equals mx plus b? Right? You think of it that way. Right? Here's the way I'm interpreting this equation. This blender maybe needs like at least 5 bananas to get going. Right? Maybe if it's like, but don't run the blender with 1 banana because then it will break the machine or something. Okay, so maybe you need at least 5 bananas. After that, like, you could have like 10, 15 bananas. Every single banana that you add, aren't you getting another smoothie? Another way to interpret this question is, what is the slope of this line? Is the answer just 1? Every single banana you add, you get another smoothie, right? After, of course, you have 5 bananas to start. The answer is 1, which is A. 14 is A. Number 15, g of x is equal to 2 minus 3 to the power of x. The function g of x is defined by that equation above. Which of the following graphs is equal to negative g of x? Oh, okay. Just turn that upside down. So negative g of x must just be, well, the negative of that, which is positive 3 to the x minus 2. See, I just reverse the signs. Okay. All right. Do you guys remember how to graph 3 to the power x or something that looks like that? Some x, y axes. I'm going to make 2 graphs. I'm going to make one that's just 3 to the x. Okay? Now, if you remember it, awesome. If you don't, you can always just do an XY table and just plot it from scratch, right? What is 3 to the power of 0? 1. A good call. What is 3 to the power of 1? 3. What is 3 to the power of 2? 9, which is like top on page. Okay, so this is going to take off and then just take off real fast, right? It doesn't actually reach a vertical asymptote, but almost kind of looks like it because it just takes off so fast. Let's go the other way. What is 3 to the negative 1? It's not a negative number, it's a fraction. 1/3. What's 3 to the negative 2? 1/9. You guys remember that these type equations hit horizontal asymptotes real fast? That is 3 to the x. That's all that is, just 3 to the x, right? Okay, now negative g of x, which we're interested in, is that shifted down 2. I mean, that's what the minus 2 is, right? The whole thing, point, gonna shift down 2. So the horizontal asymptote is gonna come down to -2. And this vertical intercept goes from 1 to -1, because 1 minus 2 is -1. And then won't that be a curve that takes this type shape? If this comes down to point, goes through there. And that would be -g of x. So do we have an answer choice that looks like that? That looks like option D. 15 is D, yeah. I'm surprised they made B an option because that looks really close to, but no, the right answer is D. Okay, you guys good? That is all the multiple choice on section 3. So there's a few more section 3 questions, but they are free response. Number 16 got 1/3 of 5m minus n is equal to 31/3, and n is equal to 3m. Okay, so it looks like a pretty basic system of equations setup, probably solved with a substitution. This is system of equations above, has solution mn. Okay, so kind of like an xy coordinate, mn. What is the value of m? Oh, yeah, let's just straight substitute. So, 1/3 of 5m minus n is equal to 31/3, where n is equal to 3m. And I'm going to substitute that because we're trying to solve for m. Okay? So it's like 1/3 of 5m minus 3m equal to 31/3. You know what? Some of you guys probably already did already. What do you do with this denominator 3? Yeah, let's get rid of that. So I've got 2m is equal to 31. Divide both sides by 2. There you go. Now, since you had to bubble this one in, you could do one of two things. You can either do 3, 1/2, or you could do 15.5. Either of those, okay? That's okay? Yep. Number 17. Paper. Zoom in here. Asaf plans to start working out at a gym. The gym membership costs $50 per month, $50 per month. And he will also have to pay a $30 one-time registration fee. Okay, so he puts down $30 up front, and then every month membership he pays another $50. He wants to spend no more than $555 for the membership and registration fee. Okay, so that's his gym budget. If gym memberships are only available for a whole number of months, what is the maximum number of months that he can afford a gym membership? Okay. All right, so I'm going to make up something crazy just to get a point. Right? What if we ran all the numbers, and for instance, the number came out to like 7.9? In that case, how many months could he actually afford? 7. Yeah, because he's looking for a maximum number, and they only sold for whole numbers. So yeah, if he could afford 7.9, well, he can really only buy 7, and then he'll just have to keep the change, right? So we're always going to round down. Right? You guys get that? Right. Let's see what this actually comes out to. So he has $555. He throws down 30 for the registration fee. Doesn't that bring him to $525 to just for the monthly costs? And then if you divide by $50 per month, or maybe you set up a very short dimensional analysis table. That's sort of what this is, right? Fraction within a fraction, dollars cancel. Okay, you get some number of months. Did you guys get 10.5 months? So what you got? 10.5 months. Okay. But you didn't write 10.5. You guys wrote what? 10. 10 is the answer. Good. Number 18. Intersecting lines LMN are shown. LMN. Great. What is the value of C? C degrees down here. All right. If you know two things, you can get this. One thing you have to know is, guys, what is the value of a straight angle equal to? 180 degrees. And the other thing you have to know is, what do the three angles of a triangle add up to? 180. If you know those two things, you can figure out this whole thing. Right, so if this is 180 degrees, and this wedge here is 97 degrees, then what's this wedge equal to?
83.
83. Okay, so this is 83. If this is 83 and this is 34, let's see, what is 83 plus 34?
Calculator is cheating.
Yeah. Oh, this is no calculator, isn't it? Okay. Thanks for reminding me about that. Well, this does come out to 117, and I'm sure you guys can add, right? If this is 117,
Yeah.
what is this thing over here? 63? That sounds right, I think, right? If this is 63, and these are total 180, then what is this? Also 117. That's the answer, right?
Oh,
So
I went wrong.
18 is 117 degrees.
I did my bad mental math. I did bad mental math.
You guys kidding? Tell you what, there is a sort of a shortcut to this, maybe a little bit, if you guys like or not. I don't know. The fact that these two have to add up to 180, and the whole triangle has to add up to 180. Isn't C always going to be this plus this, right? This angle plus this angle, which in this case is 117. So I'll save you a few seconds. Number 19. 9 times s minus 2 plus 3 times s plus 2 is equal to 7s. What is the value of s? Oh, you see that? So 9s minus 2 plus 3s plus 2 is 7s. Gonna distribute. So 9s minus 18 plus 3s plus 6 is 7s. Got that? I see 5 terms. Some of those have s, some of those are just constants. So this looks like 12s, and then minus 12 is equal to 7s. Subtract the 7s over 5s. I'll add over the 12 while I'm at it. Do a double swap. Divide both sides by 5. This is the answer. Or you could have said 2.4. So if you did 12/5, or if you did 2.4. Guys doing good so far? Okay, so total your score out of 20, because we just went over all 20. Oh, no, oh, yeah, thank you. I'm sorry about that. Number 20. Okay, we did 19. Right, number 20. Right. That fraction minus that fraction is equal to that fraction. And C is not equal to 3 over 2. Did you guys see why they said this?
Yeah, it'll be undefined.
Yeah, because you would be divided by 0, right? So they probably show up on the graph as a whole, I think. What is the value of x? Let's try that. So you got 4c plus 1 over 2c minus 3 quantity squared minus 2 over 2c minus 3. Right. I'm going to leave a space. Let's see why in a minute, or some of you guys might already. X over 2c minus 3 quantity squared. Okay, so I got fraction minus a fraction is equal to a fraction. Now, anytime you want to add or subtract fractions, you have to have a what?
Common denominator.
Common denominator. And there's a certain common denominator that is, well, denominator I should say, that is begging to be the common denominator. That's probably this guy right here, right? 2c minus 3 quantity squared. Right. Can I do this? Can I just take this middle term and square it and then add all these up? Can I do that?
No.
Ah, you guys are on. I cannot do that because I would be changing the function. I'd be solving for something totally different, right? How can I get common denominator?
2c minus 3 over 2.
Yeah, multiply top and bottom by this, because now the denominator matches all 3. But see the theory of why this works, because that fraction right there is equal to 1. So I'm not really changing anything. I'm just making the denominators match. Okay, so we got ourselves a 4c plus 1 minus 2 times 2c would be 4c, and then minus a negative, that's plus 2 times 3 is 6. You might want to break that apart into different steps, just be careful with those signs. Maybe I skipped the stuff I shouldn't have skipped. Yes, equal to x over 2c minus 3 squared. Okay. Hey, if that fraction is equal to that fraction, can I see that numerator is equal to that numerator? Yep. So I got, oh, what happens to the c's? Yeah, goodbye. So that's it. Bada boom. Aha, so now we've done all 20 of section 3. Let's move on to section 4. So now you're allowed to use a calculator. They give you the shapes again. You need to reference those. Okay, number 1. Sam's special hot chocolate recipe calls for 4.5 ounces of cream for every serving of hot chocolate. Okay. How many cups of cream are needed to make 24 servings of hot chocolate? Ooh, I think this is going to be dimensional analysis. Dimensional analysis. We've done dimensional analysis in this class a lot. So we got to have 24 servings. Every one serving needs 4.5 ounces of cream. And how many cups? Oh, and then every 1 ounce, sorry, every 8 ounces is equivalent to 1 cup. That's the table. So servings, set up to cancel, ounces, set up to cancel. I'm going to end up with some number of cups, which is exactly what's being asked for. What's 24 times 4.5 divided by 8? 13.5. And the unit is cups. Option D. Yeah, 1 is D. Number 2. Percent of music sold as CDs by year. So it looks like first few years of the 2000s, it was kind of flat, up a bit, down a bit. And then I see it dipped a lot between 06 and 07. That's actually the question. Between which pair of years is the greatest percent drop in CDs? And there's an option that says 06 to 07. So number 2 is C. Right? Now, if you wanted to be really meticulous about it, then what you could do is you could do final minus initial divided by initial. Right? Or some textbooks I've seen final minus initial divided by the average. Because there's more than one definition of percent change. So whichever one you go with, though, it should tell you the biggest drop is 06 to 07. Number 3. Oh, hey, this looks like an XY table, doesn't it? XY values. Some values of a linear function are given in that table. Which of the following defines G? Ooh, so y equals mx plus b because it's linear. You know what, just at a glance, do you guys see that every single one of these options has a different slope? Hey, I bet if we figured out the slope between any 2 points, and we just pick our favorite 2 points, that would lead us directly to the answer, wouldn't it? Let's pick these top 2 points. Does this have an increase of 6 units in the y and an increase in 2 in the x? So y over x, right? Rise over run. Is that up 6 over 2? What is up 6 over 2? 3. Slope of 3. Oh, that looks like option B. Number 3 is B. Okay. Let's double check. I mean, that was one approach. There's probably lots of ways you could approach this. Let's do this. Let's take that last point that we haven't touched yet and plug it in and see if it works. So plug in 6 for x. So 3 times 6 is 18. Plus 5 is 23. Oh yeah, it is 23. That checks out too. There's a couple of approaches you could do. Number 4, a souvenir store sells postcards and magnets. Each postcard costs $1. Each magnet costs $3. If Anna Lee purchased a total of 10 postcards and magnets, pause right here. This is really awkward wording. What they're trying to say is she purchased 10 items. Maybe it was like 5 and 5, maybe it was 7 and 3. They have to add up to 10. Okay, so if you missed that, sorry. But, and the total cost is $22 before tax. How many magnets did she purchase? We're going to have to set up our own system of equations and solve it. So let's do that. So 2 equations. the number of magnets plus the number of postcards has to add up to 10. Right? That true? Right. Again, if you did not interpret the wording that way because it was kind of awkward wording, then sorry, but that's what they meant to say. And then if you do $3 per magnet times the number of magnets plus $1 per postcard times the number of postcards, it should add up to 22 total dollars, right? Now, all those terms, every single term has dollars, so I can go shoot, 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 and I got myself a nice system of equations. You guys see that system? So let's just solve the system, and we'd really like to solve for magnets. Guess what? What I'm gonna do? I'm gonna rewrite this. I meant to put the other equation on top, and there's a specific reason for that. To do it. So I got 3m plus p is 22, and I've got m plus p is 10. Is that true? Okay. Now, there are lots of ways you can solve systems of equations. Most commonly, you can either do substitution or elimination. And I really like the elimination option for this one. Because watch this. If I subtract this bottom equation from this top one, 22 minus 10 is 12. P minus P is 0. Gets rid of the postcards. And then I got 2m. So 2m is 12. So how many magnets did you buy? 6. How many postcards did she buy? 4, right? Because it got a total of 10. Is there a 6 magnet option? Option D. Yeah, 4 is D. That's it. Number 5. If 7 times x minus y is 4, what is the value of x minus y? Oh, well, can you just divide down 7 and get the answer? Is it 4 over 7? Yeah, 5 is A. Okay. Number 6, the average annual precipitation in Orlando is approximately 13/10 of what it is in Columbus. So pause right there. Where is it raining more, in Orlando or in Columbus? Orlando by a good 30%. You guys see that? The average precipitation in St. Cloud is 7/10 of what it is in Columbus. Okay, so it looks like we're comparing everything to Columbus. And it looks like they're getting the least amount of rain in St. Cloud, the middle amount in Columbus, and the most in Orlando. Like I said, like a Goldilocks situation. If the average annual precipitation in Columbus is 1,000 millimeters, I'm glad they gave us Columbus because that's like the base value we're comparing everything to. How many more millimeters fell in Orlando compared to St. Cloud each year? Well, let's run the numbers. So Orlando, guys, how many millimeters in Orlando? 1,300, right? Because 13/10 times 1,000 is 1,300. How many millimeters in Columbus? 700, because 7/10 of 1,000 is 700. So what's the difference between 1,300 and 700? 600. So 6 should be A. 6 is A. Yeah.
That was 5.
Oh.
Is that 5 or 6?
This is number 6.
Oh,
Yeah.
okay. What was 5?
Number 5 was also A.
Oh,
Yeah.
okay, I'm fine.
Okay. That's it. Number 7. Which of the following is an equivalent form of, well, that right there. Okay, so let's just go clean that up. We got 2.6a minus 3.5 squared minus 7.3a squared minus 4.1 in parentheses. All right, this definitely looks quadratic. The game plan here, let's FOIL this out, then combine like terms and see if there's an answer choice. I think it'd be a good thing to do. So FOIL, F-O-I-L. Imagine this term times itself, right? Like side by side. So first, what's 2.6 squared? We're allowed to use a calculator, yay, is 6.76. Now that would be a squared, wouldn't it? Then outside and inside, So this times this, what's 2.6 times negative 3.5? It's negative 9.1, but remember outside and inside, so you have to double that, right? So I'm looking at minus 18.2a, and then 3.5 squared is positive 12.25. Right? Doesn't matter, it's minus because minus times minus is positive. So that is all that first piece. Then so I'm gonna do, okay, I'm gonna distribute that negative sign and say minus, let's put it over here, 7.3a plus 4.1, right? Is that true? Right, so what is this? What's 6.76 minus 7.3? Look at that, negative 0.54 a minus 18 point, or sorry, a squared. Whoops. Yeah, thank you. So it's that 18.2 a plus, what is that? 16.35, I think. Okay. I hope there's an answer choice that says that. Let's find out. Is that option D? Yep, 7 is D. You guys got D for number 7? Let's pause that right there. So hit pause point and we'll do more of this tomorrow.